Hi everyone, my name is Kevin Brown. Right now I'm going to do an example taking a look at the difference between two sample means in order to estimate the difference between two population parameters. But I'm going to actually do not just simply an interval estimate, but I'm actually going to do a hypothesis test as well. Let's take a look at the data we've got first. So we're interested in consumer satisfaction, okay? And Target's mean consumer satisfaction score was a 79, and Walmart's mean consumer satisfaction score was a 71. So it appears on the surface that Target has higher consumer satisfaction than Walmart. But again, we can't make that statement because this is just simply based upon a sample. 25 for Target, 30 for Walmart. Maybe there's a lot of variation in that sample. Maybe the sample's not big enough. Maybe that sample doesn't reflect reality, the real population. All of the people that shop at Target, all of the people that shop at Walmart. In other words, we're just seeing something in the sample. So our question is, can we say that there's a real difference, not just simply in the sample, but in the real population? So we want to formulate a hypothesis test. Now, I'm not trying to see if Target is higher than Walmart in this particular hypothesis test. Rather, I'm interested in whether they're different. Now, that wording matters. That wording is very important because it will tell me how I need to formulate my null and alternative hypothesis. And we know if we're just looking at a difference, then we're looking at a two-tailed hypothesis test. So we'd write it out as follows. We've got our null and we've got our alternative hypothesis. In this case, Target will be population 1, Walmart will be population 2. So what we're trying to say is, if we take population 1 minus population 2, they're either equal, where it would be equal to 0, in other words, being no difference, or they're not equal, which means there is some kind of a difference. Target's above Walmart, Target's below Walmart, etc. So this would be our null and our alternative hypothesis. But now we want to test this hypothesis. We want to come up with a p-value. And again, the p-value is the probability of a type 1 error, rejecting this null hypothesis when it is in fact true. So are they different enough for us to make a statement that they're different in the real population as well? So we actually need to find a z statistic, our test statistic for this, so we can find out our z-score. And I went ahead and constructed up here the standard error because that's very important for the test statistic. So let's go ahead and do this. We see that, do a little bit of math, so I've got 144 divided by 25, that's 5.76, and 4.8. So that gives me 10.56, and if I take the square root of 10.56, I get a value of 3.25. So that is my standard error for this particular problem. Okay, so what about my z-score? Z is going to be equal to x1 minus x2 divided by my standard error, which is 3.25. Well, we know that x1 minus x2 is 8, so if we take 8 divided by 3.25, we get a value of 2.46. That is my test statistic. Now, before we move forward, let's think about what we're doing here. We've got a certain bell curve, right? And we've got a mean here at 0. And if there's no difference between the two, this would be 0. But we have this value of 8, saying that there is some difference. And we want to know how many standard errors away from the mean is that 8 if we convert that to the standard normal probability distribution. So we see that it is 2.46 standard errors away. And if I go to my table for 2.46, I see that is the equivalent of 0.9931. Now what does that mean? That means that from here all the way to the end makes up 99.31% of the entire distribution. But we're not interested just simply in all that. We want to know this region. So I'm taking 1 minus 0.9931 and that gives me a value of 0.0069. Now, you might be tempted to think that we're done, but remember, this is a two-tailed test. So not only do I have a rejection region here, if it would have been far enough away this way, I also would have had a rejection region in the lower tail. And so because this is symmetric, because I could fold it right down the middle and it would be perfectly symmetric, I'm going to multiply this value by 2, and we get 0.0138. And that is my final p-value. Let's remember our rejection rule, that if that final p-value is less than our level of significance, and because we have a 95% confidence level, our level of significance is 0.05, we can reject the null hypothesis. So we can say that our alternative has reason to be accurate, and there is a real statistically significant difference between the customer satisfaction scores in Target and the satisfaction scores in Walmart. But imagine I'm interested in the interval estimate. So we know that there's a difference of 8, but what kind of margin of error might be associated with that? Well, let's go ahead and figure that out. The good news is we've already figured out our standard error, which we'll need in the interval estimate. So recall that the interval estimate is taking x bar 1 minus x bar 2, Target minus Walmart, plus or minus z alpha divided by 2 times our standard error. And this is going to be our standard error. So we'll write this out. That's 8 plus or minus 1.96 times 3.25. This value is 1.96 because, remember, the z-score associated, or the score we're going to use, z alpha divided by 2 for our 95% confidence level, will always be 1.96 if we know the population standard deviation. All right, so 1.96 times 3.25 is 6.37. So the difference is 8 plus or minus 6.37. So that's anywhere from 14.37 all the way down to 1.63. So let me express that this way. Imagine you are studying these companies and you go into a manager and you say, you work for Target, we'll say, and say, Mr. or Mrs. Manager, I found that our customer satisfaction scores are higher than Walmart's. And the manager, of course, says, how much higher? And you say, well, by 8. We're 8 points higher than Walmart. And the manager, who has a little bit of statistical background, or maybe a lot, says, well, wait a second, that was just a sample you did. How can we be sure that in the real population we're much larger than them, or we're as large as 8? You can say, well, a couple of things, Mr. and Mrs. Manager. Number one, I did a hypothesis test, and I found that that is a real statistically significant difference based upon the study. Number two, 8 is our sample mean, but I can be 95% confident that that real difference is somewhere between 1.63 and 14.37 customer satisfaction points. So this has been an example of looking at the difference between two means in a population based upon their samples for a hypothesis test and an interval estimate. Thank you so much.